Assalamualaikum and hi everyone. So today I'll show you how to solve linear equations by using Crout method. Okay, so steps to solve linear equations by using Crout method is similar with Doolittle method. Okay, so the first step is we must convert these three linear equations into metric form. Okay, so we have these linear equations, so we convert to linear form. We convert it to metric form. So we have for metric A -1, 2 and 1. Okay, this is for X, this is for Y, and this is for Z. Okay, for second equation, we don't have the value of X, so 0 for X, and then 8Y and 6Z. Okay, and then for the last equation, we have -2X plus, okay, we don't have value of Y, so 0, and plus 5Z. So this is our matrix A. Okay, and then multiply with matrix X is our unknowns. Okay, so we have X, Y, and Z, and then equals to the solution. So we have 0, 10, -11. Okay, so this is our first step. Okay, so this is matrix A times matrix X equals to matrix B. Okay, and the next step is we must find the multiplication of L and U, matrix L and matrix U. Okay, so just now I said that the steps for Crout method is similar with Doolittle method. So the difference is only the difference between Crout and Doolittle method is the formula for matrix L and U. Okay, so this is matrix A. We can get it from our first step here. Okay, matrix A -1, 2, 1, 0, 8, 6, -2, 0, 5 is equal to, okay, this is the formula of matrix L and U for Doolittle method, for Crout method. Okay, so we have A0, 0, BC 0, DEF. This is for matrix L, and matrix U is 1GH, 0, 1I, and 0, 0, 1. Okay, so we must find the multiplication of matrix L and U. Okay, for further explanation about multiplication of matrices, okay, you can refer my previous video on title Doolittle method. Okay, how to multiply matrix L and matrix U. The concept is the same. Multiplication of matrices. Okay, we must multiply row and column, row and column, row and column until the third row and third column. Okay, so here we get, okay, for the first row and first column, we get A times 1, 0 times 0, and 0 times 0. So we have A. Okay, and then we have A times G, 0 times 1, 0 times 0. So we have A, G. And then A times H, 0 times I, 0 times 1 is AH. Okay, for second row, we have B times 1, C times 0, 0 times 0, so we have B. Okay, and then B times G, plus C times 1 plus 0 times 0 is BG plus C, and B times H, C times I, 0 times 1 is BH plus CI. Okay, and then D times 1, E times 0, F times 0 is D, and then D times G plus E times 1 plus F times 0 is DG plus E. Okay, and the last one we have D times H plus E times I plus F times 1, so DH plus EI plus F. So this is the multiplication of matrix L and U for Crout method. Okay, so remember that A, B, C, D, E, F, G, H and I are just the notation. Okay, you can use any letters from A to Z to denote these letters. Okay, but avoid using O, letter O, because we don't want to get confused with 0. Okay, so after we get the multiplication of L and U, we must compare with the left side. Okay, so our left side is matrix A, so we have negative 1 to 1, 0, 8, 6, negative 2, 0, 5. So we compare both sides based on their positions. Okay, so we have A is equals to negative 1. Okay. Here I repeat, A equals to negative 1. And then we have AG equals to 2. So we substitute value of A, negative 1 times G equals to 2. So G equals to negative 2. And then we have AH equals to 1. Okay, again we substitute value of A, negative 1 times H equals to 1. So H is negative 1. Okay, and then B is equals to 0. Okay, BG plus C equals to 8. So we substitute value of B, 0. Value of G is negative 2 plus C equals to 8. So 0 times negative 2 is 0. So plus C. Oops, sorry. So C is equals to 8. Okay. And then for the second row and third column, we have BH plus CI equals to 6. Okay, so we substitute value of B. B is 0. And then H is negative 1 plus C is 8. I equals to 6. So this one is 0. 0 times negative 1 is 0. So 8I equals to 6. Therefore, I is equals to 3 over 4. Okay. And then for the last row, okay, we have D equals to negative 2. Okay, D equals to negative 2. And then DG plus E. DG plus E equals to 0. So we substitute value of D is negative 2 times G negative 2 plus E equals to 0. So negative 2 times negative 2 is positive 4. Okay, we move it to the right hand side. So we get E equals to negative 4. Okay, positive 4 transfer to the right hand side, we have negative 4. Okay, and for the last row and last column, we have DH plus EI plus F. Okay, DH plus EI plus F equals to 5. Okay, so we substitute. Value of D is negative 2 times H negative 1 plus E negative 4 times I 3 over 4 plus F equals to 5. So we calculate and we simplify. So we get the value of F is equals to 6. Okay. So our next step is we must substitute back value of A until I into the formula of L and U. So the general formula of L for Crout method is A00, BC0 and DEF. Okay, so we substitute value of A until F. So from our calculation here, okay, so A is negative 1. Okay, A negative 1, and then we have 0 and 0. Okay, 0 and 0, just write back. Okay, and then we have BC0. So B is 0, C is 8. So we substitute here. So 0, 8, B0, C equals to 8 and 0. DEF. So DEF. Okay. D negative 2. E negative 4. F is 6. Okay. So this is our matrix L. And matrix U. Okay. The general formula is 1GH 01I and 001. So we substitute value of GH and I. So we have 1. Okay, G and H. So G is negative 2, H negative 1. Okay. Okay, sorry. Okay. Negative 2, negative 1. And then we have 0, 1, I. So 0, 1. And I is 3 over 4. And the last row 0, 0, 1. Okay. So this is our matrix U. Okay. Next step, after we get the matrix of L and matrix of U, okay, so we can substitute into this formula. Okay, in my previous video I already shown, okay, how to get formula for Ly equals to B here. Okay, we substitute back our matrix L. Okay, this is our matrix L, negative 1, 0, 0, 0, 8, 0, negative 2, negative 4, and 6. We substitute here for matrix L. And matrix Y is just Y1, Y2, Y3. And then equals to matrix B. We can get it from our first step here. 0, 10, negative 11. So okay, so after we get this equation, okay, so we can solve for matrix Y. Okay, so I repeat the shortcut. Okay, the first column is for Y1. Okay, the second column is for Y2, and the third column for Y3. So from this matrix form, matrix equation, we can rewrite as linear equation. Okay, we look at a row by row. Okay, so for the first row, we have negative 1i. So we can write negative y1. Okay, so negative y1, and then plus 0y2 plus 0y3. So we don't have to write for y2 and y3. And then equals to, the solution for the right hand side is 0. Okay, therefore y1 is equals to 0. Okay, and then for the second row, we have 0y1 plus 8y2 plus 0y3. So y1 and y3 we don't have to write for y1 and y3. So we only have 8y2. Okay, positive 8y2 is equals to 10. So y2, 10 divided by 8, we simplify, we get 5 over 4. Okay, and the last row, for the last equation, we have negative 2y1 minus 4y2 plus 6y3, and then equals to negative 11. So we substitute value of y1 equals to 0, minus 4 times y2 is 5 over 4, and then plus 6y3 equals to negative 11. So we calculate, we get y3 equals to negative 1. So our matrix Y y1, y2 and y3 is equals to 0 for y1, y2 is 5 over 4, and y3 is negative 1. Okay, so after we get matrix Y, we substitute into this formula. Okay, so we have ux equals to y. Okay, again you can refer to my previous video on title Doolittle method. Okay, to know how to get this formula. Okay, where this formula comes from, ux equals to y. So u is matrix u that we get just now. Okay, this one. Okay, so this is matrix u. So we substitute into this formula. So we have 1, negative 2, negative 1. Okay, and then 0, 1, 3 over 4. And 0, 0, 1. Okay, so this is matrix U. Multiply with matrix X is from our first step just now. Okay, here matrix X is X, Y, Z. So X, Y, and Z. And then equals to matrix Y. Okay, matrix Y is here. So 0, 5 over 4, negative 1. So okay, 0, 5 over 4 and negative 1. Okay, again we multiply the left side. Okay, so the left side, this is the shortcut. Okay, so the first column is for x, the second column for y, and the last column for z. So we can get the equations from this metric form. Okay, so for the first equation we have 1x or just x minus 2y minus 1z, and then equals to 0. Okay, so we have x minus 2y minus z equals to 0. So we cannot solve this equation yet because we have 3 unknowns here. Okay, we proceed to the second row. So we have 0x. Okay, 0x, so we don't have to write x, plus 1y, so y, plus 3 over 4z equals to 5 over 4. Okay, and here also we cannot solve this equation yet because we have 2 unknowns, y and z. So we proceed to the last row. We have 0x plus 0y plus z. So x and y we don't have to write because the value is 0. So we have 1z, so z is equals to negative 1. So z equals to negative 1, we can substitute this value into the second equation. So we have y plus 3 over 4 times negative 1 equals to 5 over 4. So we calculate and then we get value of y is equal to 2. Okay, and we can substitute value of y and z into the first equation to find the value of x. So we have x minus 2 times 2 for y minus z is negative 1 equals to 0. So we calculate this, we can get value of x equals to negative 3. So our matrix x is x, y, z is equal to x is negative 3, y is 2, and z is negative 1. Okay, so this is the solution for this linear equations. Okay, these linear equations by using Crout method. Okay, so I repeat, the steps to solve linear equations by using Crout method is the same as by using Doolittle method. The difference is only the formula for matrix L and U. Okay, sorry. So that's all for today. Okay, I hope you can understand the steps. Okay, and see you again in the next video. Okay, assalamualaikum and bye.